As long as people have lived, we've wondered how we got here. Has the universe always existed, or did it have a beginning? Are we the work of the gods, or is there a natural explanation? Over the past 100 years, scientists have built up a remarkable picture of how the universe began. This tells us that everything we can see began 14 billion years ago, in an explosion from a tiny speck of immensely hot, dense matter. Does the Big Bang do away with the need to believe in God? Or does it point towards a God who created the universe? Probing the Big Bang involves looking into the depths of space using giant telescopes, and it involves looking into the depths of the atom using giant particle accelerators. In these programs, we're talking to astronomers and physicists who accept the scientific account of the Big Bang, and they believe in a God who created us. We want to find out how they hold these beliefs together. Geneva, in Switzerland, is famous for its watches and its chocolates. In the past few years, it's become famous for something else. The biggest scientific instrument in the world, just up the road from the lakeside, is the Large Hadron Collider at CERN. Nick Saunders was involved in designing some of the key instruments for the Large Hadron Collider. We asked him why it's important.
Well, Large Hadron Collider is their new machine, so it's a much higher energy machine. Why is it important? Well, it's hit the news obviously because not only because of the delays and problems that they've had with the magnets, but in addition, the Large Hadron Collider is a machine which should, if the Higgs boson exists, enable one to detect the presence of the Higgs boson, which would be quite interesting to see whether the standard model of quantum mechanics is correct or not. I think it'll either confirm or deny our current understanding of the science. It may well lead to some surprises, and when it starts to ramp up to significant energy levels, which they should be doing in the next couple of years, then we'll start to see whether these models that we have are correct or not. So it's a very exciting time for theoretical physics at the moment.
Here at the world-famous Harvard University, Gerald Gabriels is the Leverett Professor of Physics. His work on the Large Hadron Collider focuses especially on antimatter. We asked him why this is important. Surely there isn't any antimatter except in science fiction?
Of course there is antimatter. It's a well-established phenomenon, and there's a bit of it that there's not very much in reality. There's a bit of it that happens in radioactive decay. The positron is an antimatter particle. The antiproton, which we study as well, is the antimatter counterpart of the proton. We've been studying these for many years. We hold them. There's nothing mysterious about them other than that if you release them into reality, they rapidly annihilate and then they're gone.
Peter Bussey is a physicist who specializes in the search for the Higgs boson, the so-called God particle. We asked him what kind of things the Large Hadron Collider experiments are finding.
The ATLAS experiment at the LHC at CERN is going to be one of the two big experiments, which is certainly going to discover the Higgs particle and maybe other things as well, like supersymmetric particles, if they exist. We don't know whether they will exist, but we do know that something must exist because the theory tells us that the theory that we have isn't going to be good enough at higher and higher energies.
And what about the Higgs boson? If it's discovered, will it disprove God?
Doesn't tell you anything about God except that God is a mathematician, which is something we may like to talk about. The fact that there's so much really elegant mathematics underlying everything in the universe really does seem to suggest to me that there's a very clever intelligence there behind it all.
The search for the Big Bang involves astronomers as well as physicists. Owen Gingerich is Professor Emeritus of Astronomy and History of Science at Harvard University. He's been an astronomer for more than 60 years. We asked him what's the most interesting thing that he's done.
I'm battle-scarred veteran of the Pluto affair as chairman of the nomenclature committee, and we got sort of outvoted, but there we are, on whether Pluto should be considered a planet. We considered it a planet of a different class, but there were a lot of astronomers who were keen to throw it out altogether, and so we've come to a rather untenable situation where Pluto is a dwarf planet but not a planet. However, I think usage will overcome this defect.
Today, telescopes in space are making it possible to find out more than ever before. Jennifer Wiseman is an astronomer, author, and speaker. Currently, she's the senior project scientist on the Hubble Space Telescope. We asked her what's happening with the Hubble telescope.
So telescopes right now are better, of course, than ever in human history. One of those amazing telescopes is the Hubble Space Telescope, which has been in orbit now for over 20 years. And it is still doing a marvelous job of observing the heavens. In fact, last year, astronauts visited the telescope and put on new instruments and repaired some that were malfunctioning. So the telescope is bringing back both amazing images, but also what we call spectroscopy, which is a detailed study of the light from galaxies, stars, planets, to tell us what they're made of, the chemical constituents, and also looking at the material between galaxies, which helps us understand how galaxies in the large-scale arrangement of galaxies in the universe got to be that way and how they're still kind of connected with this tenuous material.
As we go on in these programs, we'll explore what the Big Bang means and how these scientists see the relationship between their faith in God and their scientific discoveries, especially when it comes to how the universe began. Next time, we'll explore why scientists believe in the Big Bang. What evidence is there for it?